Namaste everyone, welcome to the class. Now, today we are going to learn Bayes theorem and problems based on the Bayes theorem. Now, if we see the statement, the Bayes theorem states that let the event a1, a2, a3 till an means there are few events that represent a partition of sample space. Now, what do you mean by partition of sample space? Suppose this is your sample space. Then these events, they are dividing this whole sample space. So something what we have learned in total probability theorem. So this is A1, this is A2, this is A3, this is A4, this is A5, something like this. So event A1, A2, A3, An, they represent the partition of sample space, and let there is another event B on S, and if P of A1 or I will say, is not equal to 0 for I is equals to 1 to 3, means for different partitions we have a non-zero probability, and P of B is also not equal to 0, then P of AI by B is equals to, given by formula, P of AI into P of B by AI. This B by AI means it is a conditional probability of happening of event B provided A already happened. So what is the second event B? So the second event B could be something like this. This is my second event. So this is a second event defined on the sample space. Now the second event, it is B. So probability of happening of any event AI when we know that B has already occurred is given by Bayes theorem, and this is the formula. P of A1, whatever probability I want, just for example, if I want probability of A2 divided by B, that means I wanted to see what is the probability of happening of this event A2 when I know that B event already occurred, then it will be given by probability of this A2, okay, which I already know, into probability of B by A2. B by A2 means I know that what is the possibility of B when A2 has occurred, divided by summation of all these probabilities, like probability of A1 into probability of B by A1 plus probability of A2 into probability of B by A2, and so on. So if I replace this probability of A1 by a simple alphabet P1, probability of A2 as P2, and so on, and probability of B by A1 as P1 dash, probability of B by A2 as P2 dash, etc., then my probability of A I by B will be equal to P1 P1 dash upon P1 P1 dash plus P2 P2 dash plus P3 P3 dash, and so on. Now theorem is there in the textbook. You can go through the theorem. We will see problems. Until and unless we see problem, it is little difficult to understand what is this Bayes theorem and how to implement it. So let us begin. Let us see the first problem. There are in a bag 3 true coins and 1 false coin with head on one side. A coin is chosen at random and tossed 4 times. If head occurs all the 4 times, what is the probability that the false coin was chosen? We have to find the probability of getting a false coin when of using a false coin when I already know that the result is all true. So here, if I see what is given diagrammatically, if you are to represent, then in the sample space, okay, I have 3 true coin and 1 false coin. So this whole sample space I can divide in 2 parts. Let us divide like this. This part represents true coin. So let us represent this by event A1, and this as event A2. This represents true coin and this represents false coin. And there is another event that I toss a coin and I will get head in 4 tosses. A head occur all the 4 times. So head can occur all the 4 times when I use a true coin, or head occur on all the 4 times when I use a false coin. I have to find the probability that I used a false coin. That means I have to find a probability of getting A2 when I know that this event has occurred. Means all 4 um, heads I got, and I want now what is the probability that I used a false coin. Okay, so let us define here. First I will define probability of selecting a true coin, probability of selecting a true coin as P1, and this P1 will be probability of selecting a true coin. I have total 4 coin, so out of 4 coin 3 are true, so it is 3 by 4. And similarly probability of selecting a false coin, it is P2 and this is 1 by 4. Now probability of getting all 4 heads by using Orbit true coin. So if I am using true coin, then what is the probability of getting all 4 heads? Probability of getting all 4 heads. So as I am using true coin which has both head and tail, so first coin I will get as head, its probability is 1 by 2. For second it is 1 by 2. For third it is 1 by 2. And for fourth it is 1 by 2. So probability of getting all head is 1 by 16. This you can say that this is P1 dash. And similarly P2 dash will be probability of getting all 4 heads with false coin. Now when you use false coin, in that case probability of getting head, so as on false coin on both the side we have head, so probability on first I will get a head, it is 100%. On second, on third and on fourth, means on all 4 point I am going to get head only. There is no chance of tail, so the probability of getting head is 1. Now required probability will be, I want to find a probability that all 4 are there, and that is because of false coin. So it is P2 into P2 dash upon P1 into P1 dash plus P2 into P2 dash. So P2 into P2 dash, what is P2? P2 we got 1 by 4. So it is 1 by 4 into 1 divided by P1 is 3 by 4 into P1 dash is 1 upon 16 plus P2 is 1 by 4 into 1. So this is equals to 16 upon 90. Okay, you use calculator, find out, it is 16 upon 90. We cannot simplify it further. Okay, I hope you understand little bit, right? Let us see one more problem. A coin is tossed. If it turn up head, 2 balls are drawn from the urn. Otherwise, 2 balls are drawn from urn B. Urn A contains 3 black, 5 white ball. Urn B contains 7 black and 1 white ball. What is the probability that earn A was used given both ball drawn are black? Okay, so a coin is tossed. If it turns head, two balls are drawn from earn A. Means if it turns head, I will draw two balls from earn A, and if tail turn up, I will draw two balls from earn B. So my sample space, I will divide this sample space in two part. Two part, that is choosing earn A or choosing earn B. And their possibility is 50-50, as getting head or tail is 50-50. So as it depends on head and tail, we can say that P1, our P1 is probability of getting head or probability of choosing earn A will be 1 by 2, and P2 is probability of tail, and this is 1 by 2. Now if head comes up, I choose earn A, and in that we have 3 black and 5 white ball. Now it is given that I got 2 white balls. What is the probability that given both the balls are black? Okay, I got the black ball. So this is a second event, event B, which indicates that I got the black ball. Now if I choose earn A, I can get black ball, or if I choose earn 2, I can get the black ball. Now black ball is known that key I got the black ball. I have to find what is the probability that earn A was chosen. Okay, fine. So let us define P1 dash. P1 dash means if I choose earn A, then what is the possibility that I will get 2 black ball? So out of 3 black ball, there are 3 black ball. Out of 3 black ball, to get 2 black ball is 3C2 base, and there is total 5 plus 3, 8. Out of 8, we are choosing 2 balls, so it is 8C2. This is P1 dash. And P2 dash, using earn B, which contains 7 black ball and 1 white ball, so it is 7C2 upon total is 8C2. I have to find the probability that it is chosen from earn A. So our required probability will be equal to, for earn A it is P1 dash. Okay, using P1 dash, the formula becomes little simple, upon P1 dash plus P2 dash. Now P1 is 1 by 2, P1 dash is 3C2 upon 8C2. On calculator, in calculator means there is function by which you can easily calculate, and here it is 1 by 2 into 3C2 divided by 8C2 plus 1 by 2, here it is 7C2 divided by 8C2. So we put the values, and finally the answer is 1 by 8. Everything you can calculate in calculator. Now let us see the next question. In a certain test, there are multiple choice questions. There are 4 possible answers to each question. There are 4 possible answers to each question, and one of them is correct. An intelligent student can save 90% questions, can solve the 90% questions correctly by reasoning, and the remaining 10% question he give answer by guessing. A want students can solve 20% question correctly, here it should be percent in place of t. By reasoning, and for the remaining 80% question, he gives answer by guessing. An intelligent student get the correct answer. What is the probability that he was guessing? Okay, so we have to again read the question that in a certain test there are multiple choice questions. There are 4 possible answers to each question and one of them is correct. An intelligent student can solve 90% questions correctly. 90% questions correctly by reasoning means when he give reasons, understand the problem, and in 90% cases he will be right. And in 10% questions he give the answer by guessing. Here in this problem, if you see, they have confused us by giving data about 2 students. One is intelligent student and one is weak student. But they ask question only for intelligent student. So you forget what information is given for weak student. Okay, you forget what is the information given for weak student. So for intelligent student, it is in 90% of the cases he give correct answer by reasoning, and in 10% he give correct answer by guessing. And we have 4 questions. So in 4 questions we have 1 correct question and 3 incorrect questions, right? We have 1 correct question and 3 incorrect question. So we divide our sample space for intelligent students. So here in solution we will consider only intelligent students. So here consider only intelligent student. So we consider only intelligent student. So when you consider only intelligent student, then in that case your P1 which is answer by reasoning, it will become 90%, that is 90 upon 100, that is 9 upon 10. And P2 I consider as answer by guessing. So answer by guessing is 10%. It is 1 divided by 10. Okay. So what is given? There are 4 possible answers to each question. So there are 4 possible answers to each question. Okay. And one of them is correct. Okay. This I have repeated. I think there are 4 possible. This part is repeated. So let us delete this part. Okay. So an intelligent student can solve 90% questions correctly by reasoning and remaining 10% by guessing. Okay, and weak student can solve 20%. So this is 90% case of reasoning, and in this 90% case, okay, I have another event which indicates that I am giving correct answer. So this is a say correct answer. So when I am reasoning, this indicates that I am giving the correct answer, and this part indicates that when I am guessing, I am getting the correct answer. This is what about the correct answer. Okay, so I will define P1 dash. Now P1 dash is answer correctly by reasoning. So answer correct by reasoning is 1 upon 4. There is one correct answer out of 4. So when I am reasoning means I am knowing that what is correct. So as I am knowing correct, okay, getting that answer is what? It is 1 out of 4. Sorry, it is 100%. When I am reasoning, now if we see the sample space, we can divide this sample space into part. Okay, that out of 1 lakh, 20,000 people suffer from the disease. That is 2,000 divided by 1 lakh will be the, we can say that possibility that the person has cancer. In reality, 2,000 out of 1 lakh have cancer right now. So I have divided this whole 1 lakh into part. One is the cancer patients and the other is non-cancer patients. Then this is suppose test, okay, test result. Now what is given that if the person has cancer, if the person has cancer, then 95% chance is that the test is positive. If the person has cancer, then 95% chance is that test is positive. And if the person does not have cancer, then also there is a chance that the test will be positive, and that is 5% only. No? 95% accurate means, and 95% if the person is a cancer patient, we will come to know that yes, he is a cancer patient. In 95% cases, we come to know. So let us define P1. I will define P1 as probability that the person has cancer. So it is 2,000 out of 1 lakh. This will give me, I will cancel 3 zeros, 2 upon 100, that is 1 upon 50, that is 0.02. And I will define P2 as the probability that person does not have cancer. So probability that person does not have cancer. So what is the probability that person does not have cancer? It is 0.98. Yes. Now P1 dash will be like the test result. Okay, when the person has cancer, then what is the test result? So test result is that 95% chance that I will get positive. So test is positive when person has cancer. Here it is, test is positive when person has cancer. So this is 95% chance out of 100, that is 0.95. So when the person actually has cancer, in 95% case, I will get the positive result. And P2 dash means if the person is not a cancer patient, then what is the chance that I will get a positive result? So test positive, I will say test positive when person does not have cancer. So test positive when the person does not have cancer. This is equal to 0.05. Required probability. Now I know that test result is positive. I have to find that the person has a cancer. So what we can conclude about the probability that the person under test has a particular cancer? So here required probability is P1 P1 dash upon P1 P1 dash plus P2 P2 dash is equals to, now P1 is 0.02 into P1 dash is 95%, that is 0.95, divided by 0.02 into 0.95 plus P2 is 0.98 into 0.05. We calculate and we will get answer as 0.05 279. So there is a chance of 27.9%. Okay, 0.279 is that 27.9% chance is that okay, if I get a positive result, that means I am checking what I can say that I'm checking the true patient. I'm checking the patient who already has a cancer. Okay, so Bayes theorem, yes, it is too much confusing. So how you can understand it is that you understand first conditional probability, you understand total probability theorem, and then you try to get what is Bayes theorem is all about. Okay, this week also can say that the reverse probability. Okay, you can say that this is reverse probability, right? There are a few more questions in this Bayes theorem that we will discuss in our next class. Thank you for now.